stream to my Twitch, not the correct one. E. Okay.
Hello, welcome to Rust Meetup, November, Malaysia. So this time we will have this time we will have hi, welcome to Rust Malaysia Meetup, and today we will have Shawn Tan will be giving a talk about Rust from a C++ perspective. It's more of a discussion this time compared to the previous session. So he'll be sharing the details. Yeah, if you have anything, I believe you can just like chime in and talk more about it. So this time will be more of a discussion rather than like a normal sharing session. Okay, yeah, Shawn Tan. Shawn Tan. Shawn, I think your audio, I think we can't hear you. No, still can't hear you.
Testing, testing. All right. Testing, can you hear? All right. Sorry, something wrong with my mic. Okay. All right. Hello, everyone. Thanks for coming. Thanks for inviting me. Right. And like mentioned, I'm not doing a talk lah. No talk. Okay. It's not no presentation or anything like that. Just chit chat lah. Okay. Discussion lah. So if anyone has anything they want to comment or say, also just feel free to chime in at any time lah. Right. So how this whole thing came about was because I started programming in Rust recently, right? So just a bit of background, I've been doing programming since 1989 until now, so that's 30 over years. And yeah, so done a number of different kinds of things before. My primary language, I would say, would probably be C++. But of course, as a consultant, I have to do work on a variety of projects lah. So I've worked on a number of different things before. And most recently, I had to dabble, dip my toes into Rust because of the project that I'm on. And so I started to see like, oh, okay, Rust, okay, new language. So try lah. And Rust, generally based on what I found out, like Googling and reading the website and things like that, they seem to be targeting at like systems programming kind of language. So targeting like the areas that are typically done by using say C++, right? So yeah, so started dabbling into Rust a bit. I can probably say that I've probably only been really like fully into Rust for a couple of months, right? So my knowledge of Rust is still pretty rusty, not very rusty, right? So still learning lah, right? But 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 already I start to see a lot of things that conflict with me, right? This is my personal perspective, so conflict with me. there are, because of the background that I come from, right? So I'm a low level kind of developer. So I've done coding even in like machine binary language, ones and zeros, assembly, low level C, C++, like that. So I come from that perspective lah. So from that kind of perspective, I like the fact that I have access to a lot of things, right? Where as I come into Rust, I start to find that why so difficult, why so fun, want to do something, right? You have to like, clone it, wrap it, unwrap it, voila, so many things just to access the the data that I want to access. So there are little bits of things, niggling things here and there that I go like, why like that, why like that. But yeah, so that is a little bit of a brief of like my perspective on things, which is looking at it from the perspective of coming from, let's say, more low level kind of stuff. I find that wow, trying to get things done in Rust can be a bit difficult, a bit messy, which I'm not particularly used to. I can see some benefit in, let's say, for example, you were coming from a web development kind of angle. Then I can see that, for example, I find that Rust seems to treat like JSON like a first class data type, that kind of thing. So it's pretty good support for it as compared to, let's say, C++. Like C++ has like no, wouldn't say JSON is great lah. Right? We of course have good libraries to handle JSON, a variety of libraries can handle JSON, C++, but it's like a latecomer lah, right? So it's not a first class thing. But I also find the opposite is also true. Like if let's say we need to handle XML, and this particular project that I'm working on unfortunately needs to handle XML, right? Then Rust support for XML is virtually non-existent. It's very, very, very rudimentary or basic support only. So in the end, we still have to end up calling to the C libraries in order to handle XML in Rust. Even though we use Rust, but underlying it, we still have to call the C libraries to handle it because there just isn't Rust support for it. Right? So of course, one argument could be that no support, write your own support lah, make your own library lah, contribute it lah, publish it on Cargo lah. But obviously we are more interested in finishing the application rather than writing the libraries for this, right? So that is another niggling thing that I had with Rust as well. But I understand that Rust is a pretty new language, so of course support isn't going to be great. Libraries also not necessarily great. That libraries are got various quality, and some of those libraries are pretty new. Not quite sure whether cannot use. And some of the libraries also can go out of support suddenly. The developer decides to go on holiday for 2 years or whatever. Right, you're out of support for the library, even if the library was pretty popular in the past, like for example, Chronos. Right, so it's a bit of a question mark lah. So as compared to, let's say, working with from the perspective that I here got my phone on. Someone got something to say. Oh, unless accidentally left the mic on. Okay, you want to ask how many languages I know? I don't keep track. Right. So I don't count, but probably. Yeah. So because like I say, I work as a consultant. Personally, okay, on a personal basis, my personal journey, I'll say not the commercial work, my personal journey. I started programming in Go. Went down to basic, then Pascal, and then C, C++. A bit of Visual Basic, if you consider its own language, which I think it is significantly different from traditional classic design. Visual Basic. Also did of Java here and there. Those are just more like the application systems kind of stuff. Then also on if you're talking about let's say web development kind of stuff, HTML, CSS, just JavaScript. I was there since Web 1.0, so working on those since last time. Then of course nowadays if you want to consider what TypeScript, JSX, those that are like derivatives or transpiled from JavaScript stuff, can also consider lah. But that's mainly because of commercial side as well. But yeah, so yeah, and then that's just software languages. You're talking about hardware languages. My bread and butter in some sense is actually very long, right? But I started with VHDL. But yeah, so assembly don't say lah. Got whole tons of assembly that I've done. Big assembly, ARM assembly, MIPS assembly, and my own processors as well. I also design microprocessors, so my microprocessors this stuff as well. Then of course I mentioned also I've done machine language programming, so binary ones and zeros. So that was because I designed my own processor. So when you design your own processor, you may not have a compiler or assembler or anything like that available. So the only way for you to write code for your own processor is to write in binary ones and zeros. And so I've done that before. Right, so yeah, so you're counting more than 10 I got a variety of different areas. That was something that I was told. All right, I was told when I first looked at Rust, then I was like I'm pretty good at C++. I've been doing C++ for I do C++ at low level, I do C++ at high level. I understand the computers very well because I design microprocessors, right? So I know exactly how CPUs work, things like that. So I was told, oh, you know all this stuff, then Rust should be easy for you, right? In fact, I found it to be quite the opposite. To me, Rust doesn't seem to be written by or designed by people who work at the low level, but to me, Rust seems to be designed by people who come from a high level. Because there are a lot of high level kind of abstractions. Or let me rephrase, a lot of abstractions in Rust. So so therefore it like I said just now, you need to like clone, wrap, unwrap, so many steps just to be able to get something. Right. Not to mention the type safety that is in there. Right. For example, even if two custom data types are fundamentally the same, because they are maybe both derived from integers or both derived from strings or something, but in order to get like one type data into the other type of data, I need to have like define certain from or two traits and a lot of verbose code just to get something simple like that done. And then when you write code, also need to like explicitly do a lot of things, a lot of very verbose extra code. So from and then I also noticed that there seems to be a trend in the way Rust is being used. I don't know if it's just because of the project I'm working on or if it's general trend, but it seems to employ quite a bit of lambda functions or closures, right? Which is again something that is more high level stuff rather than low level code, right? So I see that the trend is like, this is my perspective now, that Rust is like a language of systems programming that was designed by people who work at a high level rather than people who work at the low level, which is the classically where you have come from. So hence, I'm struggling with Rust, not because I don't understand computers, because I don't understand Rust. Why is it like that? Okay, answer your question, happy. Right. All right. Thank you. Safety, productivity, and performance. Okay, three aspects. Okay. Okay. I answer the performance part. Performance part, I do not specifically know because I've not actually done any measurements. All right. So I can't really point out whether naturally the language is better or not. And actually, I also do a lot of training in terms of performance. I've run a lot of classes on optimizing code, particularly for C++. Right. So, the warning I always give people if with regards to performance is you can write badly written code in any language. Right. So it's not so much about the language, but rather how you understand and this is where maybe Ang Chin will actually disagree with me, but you need to actually understand how the hardware works, and then you write your code in order to exploit that hardware. That will give you the most performant code, so to speak. Right, so understanding how the hardware works and then exploiting the code, writing the code to exploit the hardware properly. That I believe is something that you can do in any language. I have, for example, in the past, improved like code performance in Java. Like Java also, not necessarily known to be fast, right? But I have managed to like help one of my colleagues last time working on our project. I just moved things around. I didn't even rewrite the code much. I just had this kind of move things around, and I bumped the performance up by 50%, right, of that particular functional program. So, and that was simply because I understood how computers work, so I could exploit the CPU to the max, so to speak. So in terms of performance, I would say it's equally as possible to write badly, slow as molasses code in any language. Right? You give somebody assembly also, they can write very, very bad, slow as molasses. Okay, so not so much the language, but rather in terms of understanding what is happening. Now, the understanding what is happening, the part there, at the moment, I can tell you I do not have that capability with Rust. I have no idea what is happening behind the scenes in Rust because I feel that the abstraction is a bit too high level, a bit too far away from the machine. But that would also be because I'm simply still quite new to Rust. I am, like I said, only a couple of months properly into Rust, full time into Rust. Right, when I write my code in C++, I can actually see the assembly code as I write it. So I can visualize it, not necessarily see, but I can visualize it. So I know that if I write my code like that, this is what's going to happen. If I write my code like this is what's going to happen in the CPU itself. I can visualize that, right? So I'm not making apples to apples comparison. I understand. But for me, as I said, in terms of the first aspect, performance, I don't really have any numbers on it to say either way. My thinking my personal thinking would probably be Rust will probably be no better than C++. It may be you can probably be as good as that but it won't properly written Rust will not be as bad as, let's say, Java, for example, right, or some other language, but it may only be about the same, right, like class performance. Right, so that's in terms of performance. Right. Now in terms of second part, in terms of productivity. The question is whose productivity, right? Developer productivity, I assume you mean not the user productivity. Right? So the developer productivity, this question, I actually feel I am extremely unproductive with Rust. But again, that could be simply due to my lack of experience with Rust because I'm still pretty new, right? However, part of it I actually blame on the fact that Rust code is extremely verbose. To perform simple things, I said sometimes I need to write a lot of code just, I need to clone it, unwrap it, I need to do so many things just to give me the damn value, right? It's not as easy as just A equals B, cannot. And worst case, A and B are different types. Wow, all right, I need to, if that, the thread has not been implemented, must implement the thread, then only can perform the conversion. So comparatively wise, I would actually say my lines code, like if you look at productivity from the perspective of lines of code, the same program written in C++ would probably be significantly shorter than the same program written in Rust. That's my personal opinion. Right? Again, it could be biased, but that's just the way I see it, because you need to do a lot more things with Rust rather than simple, let's say C++. As for safety, all right, so the question of type safety, well, one of the reasons why we have all that verbosity in Rust code is because of this type safety thing lah. They are trying to type safety lah in general lah, safety in general. They are trying to make sure things are done in a very specific way, right? Using the language, and as a result, you have to be very, very explicit lah, and therefore which results in a lot of verbosity, which is a counterpoint for number 2 lah. So, in terms of safety, maybe it's better. I don't know. I don't see any evidence that it is necessarily better, but better than a properly written like program in some language. Of course, it is possible to write that code anyway, right? You can write that C++, you can write that C, you can write that Rust as well. Right? But Rust in general would enforce things more strictly because that's the way it was designed. If let's say you compare with something like C or C++, where it's very loose, a lot of things are very loose. The developer is allowed to do anything that they want, basically. But as a result, they shift a lot of responsibility to the developer. So the developer must take responsibility for his or her code. Whereas Rust is probably the other way around, where they assume the developer doesn't know what the hell is happening. And so therefore, if the developer, they shield the developer a lot from a lot of the things happening behind the scene, and if you want this to happen, you literally need to specify very verbosely, this is that, this is that, this is that, then only you end up getting that data. Example, I'm just nitpicking. Hope that answers the question. Wow, this kind of question, I'm not industry expert. All right, but okay, so at what point? Okay, yeah. Never mind, I just answer this question first. All right, so this question is like at what point? Sorry, I remind you of the question. At what point should people look at Rust? Personal opinion, this is my very personal opinion. I don't think anybody should be looking at Rust, personally speaking. All right. Because like I said, all the nitpicking issues, the stuff that I really don't like about it. Oh, okay. So he's maybe I just mute him lah. Maybe it's my accidentally on. Alright. So if you ask me lah, my personal opinion lah, of course you guys want to learn Rust, go ahead, great, okay. It's always good to learn new things, have new perspective on things, right? I agree. So that bit I agree. Right? So we should always try new things to have new perspective on things. If you won't know whether what you are currently doing now is a good thing unless you have something else to compare it to, for example. Okay. But what kind of use case do you think Rust is good for? when I first started this talk is that one of the things that I read about online was that Rust was trying to be like, you know, the next C++, you know, that kind of thing, trying to go for the systems programming kind of area. But the way I see Rust is it seems to be developed by people who come from a high level area rather than people who come from, let's say, you know, necessarily the assembly or, you know, low level kind of area kind of thing. Right. So what I find one of the strengths I like about C++ is its ability to have that range. I've been asked several times before, what do I like about C++? I like the fact that it has a range. Some languages, for example, are only good for, let's say, designing application level code. For example, some people know that I hate JavaScript, right? And when I hear people doing embedded system JavaScript, I cry. I'm like, oh no, how can you be using that language to do JavaScript, right? Yeah, that's how I've been using the language to work on embedded systems, for example. It doesn't make any sense to me. Why would anybody do that? The runtime alone kills most embedded systems already, right? But some people obviously do it because there are projects out there to do it, right? So one of the things that I like, right, about C++ is the range, right? So the range is, for example, C++ can be used to develop at very low level, right? You can, like I said, literally have a one-to-one mapping between your C++ code and the assembly code that gets generated, right? Hence the ability to visualize the assembly as you write C++ code. So that can be very low level. It can also be working at a very high level of abstraction, which is why you know, a lot of, like for example, game companies, they use C++ as a development language for, you know, developing 3D games and stuff like that, right? High level abstractions also work as well. So that's one of the things I like about C++. And if you want to put in assembly, C++ is also very straightforward. And not much difficulty. And if you want to integrate directly with assembly code that's written in assembly, that means totally assembly code, right? Also pretty straightforward, right? Not that much difficulty either. It's because it comes from that kind of background, right? C and then C++ on top of C, that kind of thing. C built on top of assembly, that kind of thing. Obviously, you can also put inline assembly, for example, into Rust as well. But obviously, the moment you do that, you lose all the protection of Rust, in the sense that because if you're allowing people to do assembly code, you know, invoke assembly functionality directly, you're basically accessing the CPU directly. Then there's not as much that the compiler is able to help you with in that sense, because you are able to do whatever the hell you want to do, right? So that is one thing that I think that, okay, you may be able to do it in Rust, but then you may potentially lose your so-called type safety or whatever other safety features there are in Rust. So then question marks become, then why bother using Rust? Right? If you're going to lose the safety anyway, then you are just as good, you know, to use some other language as well. Right. So hence the question just now is there any particular use case or application where, you know, Rust is so-called the specialist that you must use Rust, you don't use any languages, other languages not as good, right? Generally, I don't think there is one that I can think of, but I'm also reminded of the fact that these kind of things evolve. Usually it doesn't happen the way we intend it to, but naturally people gravitate towards something. So for example, web applications, you know, written in JavaScript only because JavaScript was the only, you know, programmable language you could use. Well, not necessarily the only one, but we have VBScript as well. But JavaScript was pretty much won, right? So then people tend to use JavaScript, and then now there's talk about WebAssembly, right? But then no one's actually writing WebAssembly. They're just making other languages compile into WebAssembly, right? So languages will evolve, will change, right? They move, right? And I don't know, maybe some industry somewhere will pick up Rust as its main, right? Main language everybody in the industry likes to use. For example, I don't know, data science people tend to like Python, for example. I have no idea I have no idea why they like Python, but it naturally became like that. Does Python have an advantage in doing number crunching compared to other language? I don't know. Probably in terms of library support, maybe. But library support gets built up over time because people use it. It's not like it was born with that library support on day one. Right? So these kind of things can evolve, obviously. But if you're asking me my opinion, is there a killer app or killer area that Rust is good for? I honestly don't see one.
Okay.
Any other language out there, huh?
So not even WASM? WASM, WebAssembly.
Assembly first language to be supported with WebAssembly is which one?
I'm not sure.
C++.
Ya. Mahasiswa lagi.
C++. Oops. Let me mute another. The first language to support WebAssembly was C++. It's been around for years already. Even before WebAssembly was a thing. So is Rust better for WebAssembly? I don't know. I've never tried it for WebAssembly, but I've only tried this. I've only looked at the demos for C++ for WebAssembly, and they were pretty cool. But I think that's more a demonstration of what WebAssembly can do rather than which language you can use to develop for WebAssembly. Right. So, any other questions?
No. And as for there's another question. So one is.
Hey, where are all these questions coming from? I don't see them.
Or is it?
People feeding you questions, is it, or is it you have a list of questions?
The question is coming from you. Someone is asking them, or I think someone also asked in the Discord. So yeah, so questions are coming from multiple.
Okay, because I don't see any question here. Okay, ask.
Yeah, so the other question is, do you learn new techniques from Rust that you can apply to C++? Also related to this, I see articles. There's an article saying that people learn Rust, but he did programming for 20 years or so, and then he realized that if he learned Rust earlier, then he wouldn't need to go through all the hard, all the traps he went through, all the foot guns. So that's what other people think. Or do you think you learn anything from Rust that you can apply to C++?
Okay, first I think there's two parts to that question. Alright, so maybe I handle the one part first, is the foot gun stuff. Alright. I've also heard that as well. I've also had people tell me that when they saw Rust, they were like, wow, this is what C++ should have been. Right? I've also had people come and tell me that. I don't disagree if you're talking about C++ from 20 years ago. I don't disagree. But Rust was not around 20 years ago either. Right? And modern C++ is a lot safer than a lot of people think. So the one common problem that people always point out with regards to C++ is memory management. That's a very big issue that people always comment. Right, which led to the development of other languages, like what they call managed languages, like Java, C#, stuff like that. Because memory management was a problem. Developers just don't seem to get it right. Right, it's very tedious. You just need to be very detail oriented, very tedious. And so as a result, it created a whole class of software bugs, a whole class, right, due to memory management issues. Use after free, double free, stuff like that. So a whole class of software bugs created by this problem. Right? Yeah, that one I agree. Right? But that is if you talk about C++ 20 years ago lah. C++, right? Basically, if you code in modern C++, this kind of problems like memory management issues, most of them are pretty much gone already. So that foot gun thing, the question becomes, what is the foot gun now, right? So one of the biggest foot gun is, shoot yourself in the foot is memory management, and that issue is largely resolved if you use modern C++ properly lah.
Yeah, but Chromium, no, the Chrome and Firefox is also written in C++, but then they also get like many memory safety, even though they are still using C++ today.
To see, like, for example, you mentioned Firefox. For example, Firefox is not a browser that was written in the last 10 years. It's been around for like 20 years. Right? So there is a lot of things there, a lot of legacy code. Right? So hence, when I talk to my clients, I always tell them that, okay, what are you building now, right? If you are building something new, then of course 100% use modern C++. Don't go and touch the old C++ at all. Then you have this so-called guarantee lah, right? This thing that will work properly lah, right? But if you have to like have legacy code mixed in, then susah to guarantee lah. That's equivalent like saying that Rust is safe, but then if I have to use XML libraries that are from C, I'm still subject to the problems in C, right? And unfortunately, Rust has horrible support for XML, so can't have to force to use C libraries. So in that sense, it's like your dependency is on legacy code, and so you will have dependency on legacy problems as well. Right. So it's not saying if you see like Firefox or Chromium or whatever, you have to see what kind of work they're actually doing.
Okay, so I understand. So it means like modern C++ is okay, but the legacy stuff, if involved, is so bad.
And that's because it's old stuff. Old stuff, everything old stuff also would have been the same problem last time. Imagine if you are asking somebody, use assembly to do memory management. You definitely can, and there are people out there who do it, right? But you can still kena lah, right? Because you are using stuff like that.
I understand. So back to the original question. Do you learn new techniques from Rust that can apply to C++? I mean, like, because Rust have a lot of new concepts. Would it be useful if you learn like some of the concepts and put it back to C++? But yeah, the III is similar in Rust also now.
Yeah, so that's the thing. I understand the fact that Rust has a lot of new concepts, but I don't know. I'm not fully Rust expert, right? Obviously, I'm not full Rust expert. I only use it for like 4 months. But based on what I have used it for, and I've used it on real production code, right? Working on commercial project. There's nothing that they have there that I have not seen in C++. Put it that way lah. Right? Like I mentioned just now, Rust, I noticed that there's a lot of people like to use a lot of lambda function closures. In Rust, lambda functions have been around in C++ since 2011. Right, so we have that. RAI, you say RAI is hence your memory leakage issue should not be an issue. Right, in C++ as well. Right, so and the running joke in modern C++ is just ripping off everybody's features. Right, they're just stealing features from every language left, right, and center, and just become like a Frankenstein, just grabbing whatever. So to say, if you ask me, had anything particularly special on in Rust that I can apply to C++, for example, didn't exist in C++. I don't see it, right? Because modern C++ has a lot of new features.
Okay.
However, there is something that I think that is unique to Rust that which is the way Rust does its object-oriented, quote-unquote object-oriented style of programming. Because in Rust, they don't do it the same way as most conventional other languages take in terms of object-oriented programming. So that's a bit different. And I don't think that will ever get applied to C++, because C++ already has its well-established model of how it does object-oriented programming, and so we will just continue to do it that way.
Can understand. But just now you say Rust is difficult, but then you say you learn there's nothing you can apply it back to C++. It's very similar, but how come you still feel it's difficult when it should be like?
When I say difficult, in terms of difficult to use, right?
Or not difficult to learn.
As in like the verbs. I don't recall saying it was difficult to learn. Did I say difficult
I'm
to
not
learn?
sure. You just say difficult, so
It's
I'm
difficult to
not
use.
sure which part difficult.
Difficult to use in terms of its verbosity.
Oh, okay. So you just mean it's very
There's
difficult
like
because it's very verbose, not because it's not difficult to learn, is it?
difficult to learn in the sense that it abstracts a lot of things away. So for example, like say when I write my C++, I can visualize the assembly, but when I write my Rust, I still can't. But that could just be because I'm still new to Rust. So, but at the moment, when I write my Rust, I'm like fumbling around in the dark. I have no idea what is happening in the background. I just do it because that's the way it is done. That's all.
Okay. I guess shouldn't that be applied to any new stuff you learn because you're not familiar with it?
Which is what I keep saying. I keep saying that this is my personal opinion based
Yeah.
on my 2-3 months of using Rust. Right, I fully understand that it could be biased because it could just be that I am not yet familiar with it, but it could also just be the fact that it is naturally like that. I can't put judgment on that at the moment.
Also, Faris, I have a question. Because everywhere I go is saturated with web dev stuff, I'm curious about what you work on and what your working day is like as a system programmer.
All right, so I definitely cannot talk about the current project that I'm working on in Rust with you lah. That one confirm cannot talk. Okay, secret. Okay. But this is, I think, a more general question, like what is my like the question is a day in the life of a system programmer kind of thing. All right, so it can vary. It depends on what the system is, the whole computing stack, right? So it depends on which end we are talking about lah. So on some days we are working, like me, I'll be working on very high level application level kind of stuff. So I also do, like, for example, Vue.js, Angular, right? React, I also got do, right? That is application level stuff, right? Web application level stuff. But on some days, I also have to go down to writing like bootloaders, right? Because I need to boot the system, right? I also have to write OS, or if not write the entire OS, at least port the OS, right, over to my custom processor, for example. I've also had to work at that kind of, let's say, low level as well. So I've also had to write drivers, many drivers for a variety of hardware. I've also had to work on HALs, like hardware abstraction layers. Also had to work on lower level application stuff, right? Maybe not the web application, but the normal, computer server kind of backend services or stuff like that. Right, so it varies now because I just have done everything along the stack lah, right? All the different things along the stack. So if you ask me what's a typical day like, the typical day would be do whatever needs to be done lah, because the consulting job is like that lah. Whatever project coming you do lah, right? But if you're talking specifically about systems level work, as in like low level kind of work, it's quite interesting one as well, right? In order to do it properly, you actually need to understand the hardware quite well. You need to understand how, for example, memory works, how we address, I/O devices directly, how we handle cache coherency issues, right? How we handle, out of order execution stuff, or race conditions, quote unquote, race conditions, but these race conditions not caused by your code, caused by the hardware, right? But yeah, so you have to understand a lot of very underlying stuff. So when I train my guys, eventually, and because we are mostly working C++, eventually what I train them to do at the end of the day is to be able to visualize the assembly operations when you're writing a C++ code, because you need to be able to do that so that you know what is actually happening underneath. Yeah, so in that sense, a day in the life will involve a lot of very low level thinking rather than high level thinking, which is I think a bit different from a lot of developers work, which is a lot of high level problem solving kind of thinking, data structures, algorithms, stuff like that. At the systems level, there's a lot less of that, right? Because you are dealing a lot more with the raw, low-level binary stuff rather than high-level data structures. In fact, data structures don't even exist, most of them, right? Just dealing with bits and bytes at the very low level. That is one of the big differences I can probably think of. The thinking level is.
Oh, so maybe when you say low level, it's really dealing with hardware. Okay, so now I get it.
I'm only talking about software.
Oh, okay.
Yeah, because when
I mean a very low level, like touching the hardware, almost. Software hardware.
It's software, but you're touching to the hardware. So that is the systems level programming kind of stuff that I mean by that Yes. Like operating system.
Hi. What's the prospect of working at the low level? Do you think it's still a viable career path?
All right. If you're asking me about job opportunities, there are plenty in Malaysia, but they are mostly in Penang. They are not so much in KL. As you know, most of the electronic companies, major guys are all in Penang. Right. So mostly there. So to say, and then obviously there are a lot of multinationals there, right? They Intel, all these kind of people out there, right? So there is definitely jobs for it. The question is whether or not you're capable of doing it, right? Because it is let's say like a different level of thinking. It's not just any software. I have had clients who come to me and say that, hey, I want to retrain my staff, to do like low level kind of software, and then I ask them what's the background of the staff. Their background are all like, let's say for example, IT guys or computer science guys. Then it becomes a big question mark already, because it's like you need to understand the hardware quite well in order to work at that kind of low level systems level kind of programming. So typically the background of the developer would actually be an electronics engineer or computer engineer, that kind of direction, rather than from a computer science or IT kind of direction. So that knowledge needs to be there first, right? If it's not there, then not saying that it cannot be done, but it's just you're going to have to put in more effort, right? You have to really go and learn up all the low level stuff. Now, whether there's prospect for career growth, they hire all the way from junior fresh grad engineers all the way up until like staff engineers, senior staff engineers, all the way up also got lah. So I think got potential lah, but I wouldn't know for sure lah.
Okay, so
Does that answer your question?
you finish your answer?
Yeah, great.
Can I just add one more bit to that lah? In terms of the number of jobs available, I would say obviously the lower level systems programming kind of jobs are less lah, right? Although electronics is one of our major exports of Malaysia, right? It's one of the top 3 exports in Malaysia. But that a lot of the work that done in Penang is actually assembly and testing, right? So not so much on the design and side of things, or the development kind of side of things. So the number of jobs is definitely naturally a bit less than, let's say, pure software, like you work for a web development or you work on mobile development, that kind of thing, that jobs, the number of jobs are probably more, right? But on the flip side, I also can tell you that the pay is definitely higher as well, because smaller pool, right? Smaller pool of the source as well. And this, when I say the pay one is general, specific companies will obviously pay higher, specific companies pay lower, right? Work for some small Chinapet company, you get squeezed, right? But you know, so there's a range, but I'm just talking general, the average, so to speak.
Okay, thanks a lot for sharing that. And this is not really a question, but have you heard of the Serd library? Serde
The
or
what?
SERDE in Rust library
Sorry,
called.
serialization, deserialization. Yeah, we use it all the time.
How is it?
Define how is it?
I mean, like, because you say you use it all the time, because I thought you say the Rust library is not that good. So this is I believe this is one of the high quality.
But I did mention that JSON is like a first class citizen in Rust. That's 30 JSON.
Yeah.
Right?
So it's okay, or is it easy to use, good, or what's your opinion on it compared to?
All right.
Is there something like this
That
from
question
C++?
of serialization, deserialization.
Yeah, something similar.
When you mean similar, you mean like, for example, you can just declare a struct and then specify derive the traits, and then magically it will just do for you. That kind of thing is both I would say a good and a bad, depending on how you look at it, C++, as far as I can tell, doesn't have that kind of library. Wait, let me think. Oh no, wait. When I use my JSON library, also very straightforward one. I think it will depend on which library you're using. Because when I use my C++ JSON library, it's also very straightforward. You just basically pass it the JSON string and you pass it a struct, and it basically does the magic for you as well. Right. So I think it depends on the library you're using.
Okay, I understand. So it's also doing some reflection,
Okay.
is it, or?
I don't understand how that library specifically works. I don't dig into it. As long as you boleh pakai, I
But
pakai.
isn't that like the high level? Then you can't visualize the assembly already.
Really care lah. I mean, for the case of serialization, deserialization, I don't really care lah, because my objective is to get that data. Now, once I get the data already, what I do with that, then only I can. The serialization, deserialization is only one small portion of the entire process. Once you get the data in, do what you need to do with it. Finish already, serialize it back up, and deal. So that part is very small.
Okay, I understand. Then shouldn't, like, if you say you want to do assembly that kind of level, then shouldn't you like in your daily work, don't you do like flame graphs to do performance optimization for those?
Performance optimization, I always tell people, is you don't be like I always like to quote the famous Donald Knuth say, no premature optimization, please. Right? Optimization always first profile first, find out where are your bottlenecks, and then only go and tweak those bottlenecks. And most often the bottlenecks may not be CPU bound, and it usually is not CPU bound. Usually it's IO bound or memory bound, right? And so unless you're doing computationally intensive stuff, then that one is a different story. Let's say you're doing, I don't know, machine learning or something, computationally intensive, then you'll be CPU bound. But most of the time it's not, right? So most of the time it's typically going to be IO bound. That's most likely the culprit. Right? Then the IO could be anything, could be network, could be storage, this could be some other IO, I don't know. So find out what that is and then tweak the code there. Fix the problem there, whatever that problem is. Right. So CPU profiling and all that is not something I do on a daily basis.
So you
Think about
usually
that.
performance. Yeah.
Go on.
You go first.
So does is a speed a deal breaker for you choosing Rust, or let's say at some points
mean
Rust
for-
is slow just like Python, will you still using it?
Oh, you're asking the wrong guy lah. Just now I already said don't use Rust. Right? Because I don't see Rust having any significant advantage over any other language. No, no significant natural advantage lah. It is possible to write back code in any language. And performance bottlenecks could be caused by anything. And like I said, normally it's an I/O problem. So if it's I/O problem, then does Rust bring anything special to the table with regards to I/O? I don't know. And if right, is that if for example, if I find that Rust is very slow, will I continue to use it? Definitely no lah. Because if it's not slow, so I don't quite want to use it, then if it becomes slow, I don't want to use it. I have an excuse to say, hey, no, don't use Rust, Rust so slow, right? But that said, also I know that there's of course a lot of effort to make it better, and I do keep this in mind as well. That when C++ first was invented in the 1970s, right? A lot of people also complained that it was slow, right? So new languages take some time to mature and evolve. The thing about Rust is just that it's still very young, right? So, and one thing that I didn't, I want to mention this, one thing that I didn't particularly like about Rust is that they seem to be happy to break things as they develop, which is not necessarily a bad thing because you're willing to break away from your past and do something better, right? Or if there's something better. But it does then
Do you mean
make Rust less desirable.
do you mean break thing as in additions? Sorry. Yeah.
You will find, let's say for example, somebody randomly want to learn up Rust tomorrow, go and Google for some old Rust code. Plug it in, may not work. Because like I said, old edition, for example, right? And that can turn off for quite a lot of people, especially companies. If they know that every few years they have to rework their code, there's a lot of cost involved. Right? So that can be a question mark. And it's not just breakage in terms of the language itself, breakage in terms of the libraries too. I just realized that there are a bunch of things in the library that are also deprecated. Right, so in other words, features that we used to rely on may not be something that is available in the future. So again, if it's from a commercial perspective, that can be a deal breaker. It's a nice language to learn, and hobby project boleh lah. If it's a software that needs to be supported long term, can be a bit of a problem.
Like duplicated, like what example? For example?
ASCII, standard ASCII.
ASCII? Oh, you mean like isn't that like Rust before Rust 1?
Whatever it is before, it is a breakage.
I don't. I never heard of it.
Okay. Maybe because you don't need to deal with ASCII.
I think that might be long ago. Like which Rust version are you using such that you have
whatever the long ago, that's the point I'm trying to make.
Okay, I understand.
You get it? A code that, let's say, for example, I wrote, let's say, 5, 6, 7 years ago, whatever, long time ago. The so-called long time ago can't be that long. Rust is not that old. Okay? So let's say, I don't know, 7 years ago, 8 years ago, you wrote a piece of code. Today, that code can die on it. Tomorrow, that code can no longer work on it. In other words, somebody needs to go and fix that code, needs to replace that code, needs to rework that code. That is cost. Right, so the question is, are you able to afford the cost? And if that code is everywhere, all over your code base, that will be a lot of cost.
Okay.
And this is not some random third-party library.
Yeah.
If random third-party library community supported one, understand that one. It's just like any other open source project you find some third-party library, and the fella suddenly tomorrow is like, I don't want to do already. I want to quit already. I want to go to, I want to retire on the beach somewhere already. Or then you are left hanging. The one you cannot blame anybody because it's a third party. But this is an example of a standard library.
Okay, understand. And the other questions in
I so happen encountered it this week because the need came up. We had to deal with ASCII. We cannot deal with use standard string. So it's like shit. How to do this? Like, then I find okay. Oh wow.
why
Rust,
why isn't so you need to deal with the 7 bytes rather than ASCII 7.
if we this particular application, if we use UTF strings, die.
So you need to do like in 7-bit or oh
We tried, and died. All right, and we do ASCII boleh. Right, so there are things out there that are not UTF-8 or UTF-16 or UTF-32 compatible. There are. Because again, Unicode is something new, right? It's not something that's been around for a long time.
okay, I understand. So you mean I hit some edge cases? Okay, first time I've heard.
Straight line case, not edge case.
Okay,
Yeah.
I understand. Yeah. So there's another question. What are the things you wish you have known before you started trying Rust?
Oh, wow. Oh wow. Can I say that I wish that Rust didn't exist? But okay. When I first started Rust, I don't say I wish I know lah, but when I first started Rust, I did sort of like do a little bit of a keep tracking. When I was learning like initially learning, I wrote a series of tweets just to track like, oh, Rust does things certain ways. Oh, Rust does things certain ways. Right. So I wish there might have been a more comprehensive like ready-made list somewhere lah. Right. Initially when I first started, I didn't find any of that. There's a lot of like guides on how to do Rust, a lot of learning guides on how to do Rust, but because I come specific background, right? So for example, I started learning Rust and I was like, oh, okay, so Rust move statistics are default, right? Everything is move, not copy. Whereas in C++, move statistics are, you have to be explicit lah. You have to specify you want to move. By default, it is copy semantics, right? Well, Rust is the other way around, right? So by default, everything is move, right? If you want to copy, you have to specifically clone, right? So yeah, so there are a lot of little things like that. I think I made like a long list. And I was like, what is question mark? What is question mark? Why everywhere I see Rust got this question mark? Oh, there's one thing again I don't like about Rust. They invent shortcuts in order to simplify their verbosity because they know the language written naturally has to be very verbose. So to reduce the verbosity, shortcut. Like for example, the question mark. Right? I'm like, oh, okay, this question mark, it's like a jargon, right? If you know, you know. If you don't know, if you're somebody coming from the outside, you look at it, you go like, apa ni? What is this? Okay. All right. So so that there are little things like that that I sort of made a list like on my Twitter. I
Okay,
just
let
added
me
like 10, 12 items
so
or something like that.
so you don't like the question mark. So do you prefer something like the if error not equals to nil in Go?
I don't know Go, never
Sorry,
used it
never
before.
mind. So basically it's like rather than doing the if equals to question mark, you don't rather than doing the question mark, you do like a full match. Do you prefer doing a full match in Rust? Your Rust can match the okay and
The question
error
is, why do I even need to do the full mesh? That should be the question.
because you want to do some error handling to handle some
Okay, let's break up the story of error handling now. Oh, I really don't like Rust's way of handling errors. Returning results all
so
the
you
way
prefer
up.
the what is that called? So you prefer like implicit
I prefer
error
C++
handling?
exception handling mechanism. It's a lot easier to handle.
Yeah, C++ and other languages they use the implicit error handling where they throw. Yeah, so I prefer that. But the issue with that is every time I need to see, I need to know what is the error. I need to go dig the source code to see whether this code will throw anything. I don't know. So every time I go dig, like I mean in Python, I go dig the source code. I go dig like 1 layer. Oh, I still can't find error. I go dig 2 layer. Suddenly I see error. Okay, I need to handle this error. Then I go dig 3 layer. Then finally I see, okay, yeah. So at least that's what I don't like about the implicit error handling. So I would prefer something like explicit error handling. The error tells you exactly what error is it. So what do you think of that?
Explicit error handling everywhere lah. In other words, making again your code very verbose. Which brings back to my topic of Rust is very verbose.
Okay, I understand.
Then it becomes very, 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 very verbose lah, in other words.
Oh, maybe
I prefer that.
continue.
Sorry,
Yeah.
anyone got any other question? Yeah.
So we can continue answering the question like what are the other things you wish?
A bit of like why I prefer the C++ way of handling exceptions. Because I can handle them at a particular point, for example, and I can do a catch-all. Right, so no matter where something happens, I can eventually catch it and do something about it. It's a lot more difficult to like do this like Rust, but in the sense that it's very verbose. Right, you want to catch it, you can catch, but then when you catch, you also need to, if you are lucky, it's the standard error. Not so lucky, some custom error, right? Then your matching of that custom error, you only match all the possible kind of custom errors. Then it can become again a lot more verbal. When all I want to know is, if the error, what is the error? If I want to display error message to the user, what error message I have to display to the user?
Yeah, but
With
if
with
it's not
C++,
verbose,
it's
how
just
do you
one
know?
line. So with C++, it's just one line, 2 lines. Catch the standard exception, and then you get the message and you display to the user. With Rust,
but,
the same thing.
But what do you know? What kind of custom like a specific error you want to handle? Do you always need to cache and print it out first before you know what error is there?
No, it depends on what you want to do with the error, right? So if let's say I want to display the message to the user saying that there was an error, right? With
I
C++,
mean like
at one
for
point.
example, when you are doing development, then you
Yeah.
don't know what kind of
So
error.
if let's say I want to do it in C++, I can do it at one point. But if I want to do it in Rust, it's a lot more difficult to do in one point. I need to actually do it in different points, and sometimes I may need to remap the errors from one particular error type to a different particular error type so that it can be passed up, that kind of thing. So it's a lot more messy, I feel.
So you need to know the upper levels of function to know what kind of errors it is. So if it's written by someone else, then you doesn't know what errors will be passed to the outer layer. Unless you go dig in the source code or you cache all, then like everyone cache them all.
If that's so, yeah, but if let's say your argument against doing exception handling like that is you have to dig into the source code, then my answer would be, dude, what's wrong with digging into the source code? Right, that is part of the job, isn't it? That's why the source code is made available. Unless you tell me you have no access to source code, then I'm stuck lah. Right, but if the source code is there, then isn't that part of the job? To dig into it.
So you mean like there's supposed to be your job, is it? I can't hear you just now.
If let's say your argument against doing like centralized exception handling like that is that you can't tell where the thing went wrong, you need to go and dig in to the source code to find where is the source of the exception, because maybe the source of the exception is very, very many levels down, right? Then my answer is like, what is wrong with digging your source code lah? Because source code is available for a reason, and it is available to you, then it's part of the job lah to understand the source
Okay,
code.
understand. Yeah. So I another question from myself. Because you have used both C++ and Rust, what do you like in C++ that you wish is in Rust, or what do you like in Rust that you wish is in C++? Or okay, explain both, like some situations that you can see.
Okay, maybe this is again due to my lack of experience with the Rust as a whole. But I like the fact that C++ gives the developer a lot of control over a lot of things, including the build and compilation process as well. I've not delved so deeply into Rust compilation process yet, right? So like I said, I'm not quite sure how it works there. But I've had to write some random like build.rust kind of stuff to actually do some weird passing of parameters and stuff like that to the underlying C++ compiler, which is invoked by Rust anyway. So I find that it's a bit sad that it has to be done that way. I hope you know what I'm talking about.
I understand, because you want to compile C++ and use it in Rust. Yeah, that's the way.
No, I'm not. I need to link, like I said, I need to link my Rust against XML, which is not a Rust thing, right? So I've had to struggle a lot with the Rust build process, which I find that again is due to the fact that they try to automate a lot of things. They try to abstract a lot of things away.
Cargo.
Great if you are walking the straight and forward path, right? But not so great when you're trying to make tweaks or changes.
From what I know, if you want to integrate other language to Rust, it's straightforward. So like you say, just put the C++ in the build.rs and link it. So you just put like that 1-2 lines.
Not unfortunately now in this particular project, we were on not 1-2 lines. It became a lot more than that because of not just the thing, but also the environment that we were operating under. Right? Because we are not building on our dev machines, we are building on the cloud, so a lot more messy.
Okay, but like but what I'm trying to say is, like, let's
and
say
we were also cross-compiling. So even more messy. Okay. But yeah,
what I'm trying to say is, like, let's say if you have a Rust project, but you want to integrate it into a C++ project, that will be more troublesome in that case.
I would never do that. Let's put it that way. If I'm gonna work in C++, just C++. No need to go and pull Rust in. No point.
Yeah, that's what I'm saying.
Just use C++.
Usually the way people usually do is just you write the C level, the C, what's it called? Write the C interface from Rust, so you expose the Rust as C interface. FFI, CFFI. Yeah, that's usually how people do it. But if you want to integrate the Rust code directly into the project, usually it's not that straightforward. So you prefer like writing your own makefile and building. So that's what you prefer.
Yes, definitely. It's because I have more control over what I'm doing. Let's say I come from old school, low level kind of thing. So I like to be in control of what I do because I know what I want to do. And then when everything gets hidden away from me, I get very worked up, very stressed out. It's like, walao, how to do this, man? Walao, how to do that? I have to do so many things just to do this. Walao, why lah? Why lah? Sometimes I go like that. It's not just my company with Rust. There are a lot of other technologies that are fancy and new that I'm also looking and going like, why lah? Why have to do that?
So generally, it means you also don't like the cargo and
we just had a problem recently where one of the cargo libraries that was supposed to be at a particular version turned out to be not in that particular version, even though it is specified as it is that particular version. So in the end, we had no cargo tool. The tool is one thing. Sorry, the crates is another thing. But yeah, so we cargo is, to me, it's like replacement for bag lah, right? Tries to be very smart, but again, same formula. It's like it can be a bit difficult if you are not trying to do what it wants you to do. And yeah, if you are a new guy coming in, depends on which direction you're coming from. If you're coming from, let's say, web development, where you got things like NPM, stuff like that, then you may think, oh, okay, this is a very similar kind of thing, right? Build process is very similar kind of thing. Specify my dependencies in the JSON file or a TOML file or whatever, and then magically everything gets put and built, right? But if you're coming from a different kind of environment like me, then that to me is, wow. I built one language, I built one project, I need to pull in so many, like hundreds of megabytes of, or maybe gigabytes of libraries and build them one by one. That may or may be a good thing. And then I built another project which uses the same number of dependencies. It also go and pull down again. Luckily, I'm not being charged by the megabyte for my internet downloads. Otherwise, I'll be crazy. Example.
Okay, so yeah, so I understand. But doesn't do you find the crates.io a leverage? You know that there are many crates out there.
Oh, you just asked me the question that I was actually complaining about just now. Leverage, yes, but is it a good thing? Not necessarily. Like, there is a real scenario, real case. One project, the project we're working on, we use this particular library, this particular feature in this library that is supposed to be in this particular version. We specify all of that nicely in the cargo TOML file, right? This particular dependency, this particular version. It pulls it from cage.io. We see it downloaded, we see it built, and then our code cannot use it because it doesn't exist. So in the end, we had to pull it directly from the GitHub repository, specify the same version number, the same tag, and then it works. Right. So yes, good and bad lah, because I think the way crates work is voluntary kind of thing, right? So if the data in there is not curated properly, things get out of sync, or for some reason, then you'd have no idea what you're pulling in because it's a black box.
Yeah, I didn't get it. But do you mean you look at the original GitHub website, but then the people added a new version in the GitHub, but then they didn't upload the crate version?
The crate version is the same version as the one on GitHub. The code is different.
Like how different? You mean like even the code inside?
The function that you wanted to use didn't exist.
Oh, is it because you didn't enable the GitHub the crate feature?
No, we pull from crates first. We pull the feature. Everything
No,
got.
I mean, you know, Rust have a feature gate, is it?
No, it's not that the function doesn't exist. Okay, the function got renamed from small character become big character. So that was the difference.
Huh? I never heard of a case like this.
You have never heard of it, but this is a real case that happened to us. This particular library that we're using.
Okay,
And the saddest thing is, this particular library is a commercial library. There's a company that's supporting it. It's used by commercial companies. So I really wonder, wow, then how come no one else has this problem, right? But the version in there is using the old version code. The number is new number, but the code is the old version here. And we were using the new version in the code. So that was the conflict. It's one minor 0.0 something like that, something, one difference.
Okay, I understand. Now, yeah. What about you say some suggestion, like what do you like in C++ that you wish is in Rust?
I like more control. Maybe because I'm a control freak. I like the ability to let the developer do what they want.
So
But this will be against the whole concept of Rust, which is trying to stop the developer from doing anything they want and to do things the so-called proper way.
okay, so let's say if you have a superpower, then you want to like remove cargo and then write a make file and do Rusty yourself, is it?
If I had superpower, the issue of supply chain, right, the cargo thing, this and the build process. Cargo actually do two things. As I said, one is the crates part, one is the crates thing, which is the supply chain, and then one is the build process, which is the make thing. Alright. So for me, is if you ask me, all these tools already exist, and not just exist. There are so many different types of these kind of tools around. Why are we inventing another one lah? Right, and then inventing a new language along the way lah. Another language. Why? We need it. Does it present a significant advantage over anything existing? I don't think so. So I think those things shouldn't have existed lah. Let's just use something that works and works well. Simple understand. Yeah, and in terms of the Rust language itself, okay, the compiler, like I said also, I would like more control over the compilation process, step by step, rather than again some black box. And yeah, the language itself also, yeah, if I had the ability to rewrite Rust, I would probably rewrite it differently lah. It's a good idea to have a C++ that doesn't have the legacy baggage of C++. That one I agree, right? Because I said it will solve a lot of problems. But unfortunately, C++ has to maintain that backwards compatibility, so it's the baggage. So if you were to ask me to invent a new language that is meant to target C++, but maybe without that baggage, then I would think, okay, good idea. Something like that.
Okay,
Can answer?
Yeah, I understand.
Yeah.
What else? Do you have any questions?
Anyone else? Any question?
Let me think.
Alright, no question. I just close lah, maybe lah. Right, since we only have a few minutes left. Yeah, so although I sound like I'm bashing Rust a lot, right? But I also understand that it is trying to do something. And I think trying to do something is better than not doing anything. They're trying to fix a situation that at least it's an attempt lah. It may not turn out to be the correct solution. We don't know, right? Maybe tomorrow somebody else will come up with a new language that's different from Rust, and everybody decide to adopt the language for whatever reason, right? We don't know. So I think generally, okay, it's a good idea, and I will also encourage people to learn, right? Because like I mentioned just now, unless you learn something different, you won't have something else to compare it against. Right? If the only thing you know is let's say C++, then you will have no idea what else is out there, whether C++ is good, what is good about it, what is bad about it, you also know. Right? If the only tool you have is a hammer, then every problem is a nail, so to speak, right? So yeah, so learn, always good thing, right? Learn new things. But what my so-called my needs and my my comment and complaints about Rust is generally from my perspective, right? Because I come from my particular kind of background, right? Very low level kind of stuff, right? Which Rust is very a bit more difficult to do with Rust. Yeah. So so that's just that lah. But
thanks a lot for sharing. Wait, first I have some questions to leave first. Yeah, so I'm wondering, because you say you are do you find the compilation time an issue? Because I hear people saying Rust is slow in compiling.
Rust is definitely going to be slow in compiling because of the way it works, right? It has to do a lot of other things, and then after that it falls back to underlying it is still using your underlying C++ chain, right, to help you. So it's doing extra work, right? But do I find it's an issue? Generally no lah, because I'm pretty used to long build times for complex projects. Even if you write it in, let's say, some language like C or C++, it can take a long time to build as well. Imagine like Linux kernel, right? Rebuild the Linux kernel, right? It's a complex C project. It also takes a long time to build. And since I'm used to that, so I don't I don't complain so much about the build time, so to speak.
Okay, so thanks a lot for sharing the information. Hopefully you'll find Rust useful someday. And
Using
yeah,
it, right? So have to use,
yeah,
so use lah.
or maybe next time when you find it useful, you can come back and say that, oh, you finally found something useful.
Next time any personal project also, I'll be like, personal project, okay, C++.
Okay, thank you.
Thank you very much for having me.
Alright, thanks everyone for joining the session.
Thank you all for coming as well.
Yeah,
Good
bye-bye.
night. Bye.